Hi class, in lesson 7.4 we will be writing algebraic expressions. Learning targets for today, we will write expressions, write algebraic expressions to determine values for real-world situations, and determine the parts of an algebraic expression. Key terms that you will see here that were on your knowledge rating scale: numerical coefficient and constant. We did talk about the word evaluate. We will be evaluating an algebraic expression as well in 7.4. Let's take a look at problem number 1 on page 494. We're going to start off today with writing expressions. Number 1 says that a school lunch costs $1.85. Use your calculator to determine how much money is collected for each situation. Write the numerical expression you typed in your calculator for each. So you're going to go ahead and do letters A through D for number 1. I would also like you to do number 2 and 3. For number 2, it says to write a sentence to describe how you can determine the amount of money collected for any number of school lunches purchased. And for number 3, to write an algebraic expression that represents the total amount of money collected. N is going to represent the number of school lunches purchased. Here are what your answers should look like for number 1, A through D. If I have 55 students, $1.85 times 55 gives me $101.75. Letter B, 185 times the 123, $227.55. Letter C, $1.85 times 2013 gives me $3,724.05. And finally for letter D, $1.85 times the 1,512 gives me $2,797.20. The sentence that we need to write for number 2, I could multiply the number of school lunches purchased by $1.85 to determine the total amount of money collected. The algebraic expression then that we should use for this problem situation, if n is representing the number of school lunches purchased, 1.85 times n. If we take a look at number 4's problem situation, the cost to rent a skating rink is $215 for a 2-hour party. The cost will be shared equally among all the people who attend the party. Use your calculator to determine how much each person will pay for the given number of people that are attending. So that's what you're going to answer for letters A through D. Again, for number 5, you are writing a sentence to describe how you can determine how much money or how much each person will pay to attend the party. And for number 6, write an algebraic expression that represents how much each person will pay to attend the skate party. P is going to be the variable you will use to represent the number of people attending. If we take a look at number 4, A through D, the key phrase that we should see in this problem situation is shared equally. That should tell us that we are going to be using division to solve all 4 of these problems, A through D. If I have 25 people attend, each person is going to pay $8.60 for letter A. For letter B, 43 people, each person will pay $5. C, 81 people, each person will pay $2.65. And for letter D, 108 people attending, each person will pay $1.99. The sentence that I should be writing to describe how I can determine how much each person will pay to attend the party. You can divide the cost to rent the skating rink by the number of people attending. For number 6, the algebraic expression that we are looking for, remember P represents the number of people attending, 215 divided by P. If we take a look at the top of page 496, number 7 says Jimmy has 3 300-minute international calling cards. Complete the table to determine how many minutes remain on each card after each call. So go ahead and fill out the table for number 7. For number 8, again, we are writing a sentence to describe how we calculated the number of minutes remaining on the calling card. And finally, for number 9, we are writing out an algebraic expression to determine how many minutes remain after each call. We are going to let C represent the duration of the call in minutes. Here is what your table should look like for number 7. If the duration of the call is 33 minutes, then the number of minutes remaining on the calling card would be 267. A 57-minute call, 243 minutes would be left, and if the call was 1 hour and 17 minutes, we would have 223 minutes remaining on the calling card. If I take a look at number 8, the sentence that I should have written down, you're going to subtract the number of minutes of the call from 300 minutes. So you're looking at the duration of the call and you are subtracting that from 300. For number 9, the algebraic expression to determine how many minutes remain after the call. C is representing the duration of the call in minutes. 300 minus C is your algebraic expression. Let's take a look at the bottom of page 496. Now you are going to get some practice writing algebraic expressions with some different problem situations. For number 10, I would like you to do A through D, write an algebraic expression that represents each situation. For letter A, if a pencil costs 17 cents, how much will you spend if you buy P pencils? 0.17 P would be the algebraic expression you would use for letter A. For letter B, you can run a mile in 7 minutes and 30 seconds. How long will it take you to run M miles, assuming you run at a constant rate of speed? 7.5 M would be your algebra expression. For bins, you want to have the same amount of snacks in each. Again, if we're looking for those key terms or key phrases, same amount of snacks in each. You should know that you're dividing for this algebraic expression S divided by 4 for your expression for letter C. For letter D, you want to share equally with your friends. If you have F friends, how many stickers? 250 divided by F. If we take a look at number 11, we are going to be writing an algebraic expression that represents each word expression. I'd like you to do letters A through F for number 11. Here are the answers that you should have for number 11. Letter A, 6 times a number. N would be 6N. Letter B, 5 more than C. You could have 5 plus C or C plus 5. Letter C, H minus 7 is going to be your expression. Letter D, X plus 1. Letter E, 3 times Y, 3Y. And letter F, 9 minus M. Next, it reminds us that we have written many different algebraic expressions, each requiring one of these 4 operations: multiplying, adding, dividing, and subtracting. Let's take a look at number 12 and let's consider each of the algebraic expressions that we see that are shown here. Example 1, we have 3.45n. Example 2, we have n divided by 7. And example 3, we have n plus 12. What I would like you to do for letter A is to write a sentence to describe each example. For example 1, 3.45 times any number, which is n. Example 2, any number n times 1/7, or any number n divided by 7. Remember, dividing is the same as multiplying by the reciprocal, so that's why we can also read that as any number n times 1/7. Example 3, 12 added to any number n. Underneath the letter A, it says that a number or quantity that is multiplied by a variable in an algebraic expression is called the numerical coefficient. If the variable does not have a coefficient, then the numerical coefficient is understood to be 1. That's a very, very important part of understanding what a numerical coefficient is. If you only see a variable, then the numerical coefficient is understood to be 1. A number or quantity that does not change its value is called a constant. So what I would like you to do for letters B and C, it asks you to state the numerical coefficient and state the constants in each example. So go back up to example 1, example 2, and example 3. State the numerical coefficients and constants for each. Let's take a look at letter B. The numerical coefficients for example 1 would be 3.45. That's what you are multiplying by n. For example 2, remember, multiplying is dividing is the same as multiplying by the reciprocal. So we can take 1/7 and multiply that by n. That would be the same as n divided by 7. So 1/7 is our numerical coefficient for example 2. Example 3, we just have the variable. Remember, if the variable does not have a coefficient in front of it, then it is understood to be 1. If we take a look at letter C, we are looking at the constants for each example. Remember that a constant is a number or quantity that does not change its value. For example 1, 0 would be our constant. Example 2, 0 would be our constant. And for example 3, 12 would be our constant because we are always going to be adding the variable to 12. Let's take a look at number 13 at the top of the next page. We are going to be writing the meaning of each algebraic expression in two ways. I went ahead and showed you an example for letter A. We have 6t plus 3. So if I want to write that out, the meaning of that algebraic expression two different ways. One example could be 6 times t plus 3, and the other example that I could use is 3 more than 6 times t. So that's what you are going to do for letters B through F for number 13. Two ways that you could write letter B: 2 minus 4 times s, or you could have 4s is less than 2. Letter C, B minus 5, or 5 less than B. Letter D, 3 times x minus y, or y less than 3 times x. Letter E, 10 plus r, or r more than 10. And for letter F, 10 times r, or r times 10. If we take a look at problem 2, now we will start to look at evaluating an algebraic expression. To evaluate an algebraic expression means to determine the value of the expression. When you evaluate an algebraic expression, you should substitute the given values for the variables and then simplify the expression using the order of operations. So let's go ahead and take a look at number 1. We are going to write the meaning of each algebraic expression, then we are going to evaluate the algebraic expression for the given values. So go ahead and do letters A through D. Remember, you're writing the meaning first, then you are evaluating. Let's take a look first at letter A. Now remember, for all 4 of these, you may have written the meaning a little differently than what I have here. We had to come up with 2 examples in the previous example that we went over. For letter A, we have 3 times x minus 4. If you follow the order of operations, 30 minus 4 is going to give you 26. For letter B, writing out the meaning, 11 minus s. When we subtract 11 minus 2, we get 9 for our answer. For letter C, t minus z, 10 minus 8 is going to give me 2. And for letter D, 5 minus y divided by 4. When you subtract 1/2 from 5, you get 4.5 for your answer. Let's also look at letters E and F. Again, we are writing the meaning of the expression and we are evaluating the expression after we substitute the value of the variable. For letter E, the meaning, 7 plus 5 times A. If I follow the order of operations, 7 plus 100 is going to give me 107. For letter F, the meaning, B divided by 4. 8 divided by 4 is going to give me 2. Let's finish up problem 2 with number 2. It asks us to complete each table. What I want you to do is letters A, B, and C. For letter A, you can see that my variable is H. All of the numbers underneath H are the values that you have to substitute in for the expression that you see on the right. For letter B, my variable is M with all the values underneath it. For letter C, my variable is Z with all the values underneath it. Again, you are carrying out the order of operations in order to figure out what the value is of the algebraic expression. If I take a look at letter A, if my value for H is 2, my answer is 4. 7/3, my answer is 5. 5 1/10, my answer is 13 3/10. And for 5/6, my answer is 1/2. For letter B, my variable is M. If my value is 0, my answer is 1. 2/3, I could have 5/3 or 1 2/3 for my answer. If M is equal to 4, my answer is 5. And if M is 1.7, my answer is 2 7/10. For letter C, if my variable is 1, my answer is 5/3, 2 7/3, 5 13/3, and 11 25/3. If you converted any of those improper fractions to mixed numbers, let's take a look at what those would look like. Here are the mixed numbers for the improper fractions if you ended up converting them for table C. That's going to do it for lesson 7.4 and writing with algebraic expressions. Please let me know if you have any questions. Thanks.